So in prep for 22, let's have a look at the 2018 paper 1, question 1 to 5 in this video. Nice easy start in this year. Only one linear pattern begins with 1/7. Your knowledge of linear patterns is the first difference is the same. So you're adding 6 on, adding 6 on, adding 6 on for an easy 5 marks in question 1. Part 2 was worth 15. If you can manage to get this quadratic pattern, there's loads of possibilities here. The first difference is 6, and the second difference can be whatever you want it to be, but it has to be the same. So we need to start down the bottom here. So we make the second difference 2. You can make it any number. We'll do a second example as well. So working our way back up, this number would have to be 8 for the difference between 6 and 8 to be 2. This number would have to be 10 for the difference between 8 and 10 to be 2. So now we have a quadratic pattern. We can work our way back up. So 7 and 8 is 15, like 1 and 6 was 7. 7 and 8 is 15, and you can just double check there. The difference between 7 and 15 is 8. 8 and 15, 23. Difference between 15 and 23 is 8. Just double check each time, and then if we add 10 on, we're going to get 33, and the difference between 23 and 33 is 10. So this forms one quadratic pattern. If we do a second one maybe up here, 1/7 is all we're given. This difference is 6. If we take the second difference to be 4, 6 and 4 would be 10. This number would have to be 4 too, so this would have to be 14, and then you work your way back up. 7 and 10 is 17. 14 and 17 is 31, and so on. The next number, 6, 10, 14, 18, 18 and 31 will be your 49. You guys can fill that in yourselves. Maybe come up with 1 or 2 more before moving on to question 2. Question 2, Phil is an athlete. The graph below shows the number of calories in kcal, kilocalories, she burns per hour depending on her heart rate. You all know that calories burned will go up as heart rate increases. Think of exercise or running for a bus a little bit too fast. And you're told here, note the axes do not start at 0, 0. So we just go down here and have a look. It starts at 100 and 200. Use the graph in part 1 to estimate how many calories Phil would burn in 1 hour if she had an average heart rate of 170. So we just double check which one is average heart rate. Let's see this one. We go to 170. We go up to our graph. Just doing the last few dots. Looks like it's just double check it's on the same line. You're going to have your ruler against it. Then you put your ruler on this line here that we're going across, and you'll get to this middle part. 750 in here. Just double check and take your time. 750 in the box given. And then use the graph again to work out Phil's average heart rate when she burns 300 calories in 30 minutes. So we go here to 300 calories. So I'll just change colors here. You may be tempted to just go 300 and across, but if you look at the question that I have underlined, 300 calories in 30 minutes, and the graph is calories burned per hour. So if we double this, this will be 600 calories in 60 minutes. And now we have it per hour. So we need to go to 600 calories. Cross like this with your ruler. This is the dot. And you can see underneath which one it's going to be. 150, 160 in between will be 155. So don't rush into the question. Double check what this one is, the units. This one is the units. You have loads and loads of time, 15 minutes to do this question. Part A only takes a little bit. So on to part B. Phil runs a series of stages. In each stage she runs a slow run of 60. Jump down now. Stage 1, slow run in meters of 60. And then a sprint. Sprint in stage 1 is 50. In each stage, after stage 1, she sprints 50 more than she did the previous stage. So in 2, she's slow run 60, and then sprints 100. Sprints are getting longer, they're going up in 50s, so you can see the pattern. This one will be 200 and this will be 250, and each slow run is 60. And this column, just double check, this is total distance in meters. Now total distance in meters is of each stage, because you can see if we go left, stage 1 she ran 110, 60 and 50. Stage 2 she ran 160, 160, not stage 1 and 2 added together. So this is going to be 150 and 60, or just add 50 each time, 210. You can see this is a linear pattern. This will be 260 and this will be 310. And down here, N, she's still going to run 60 meters every stage. That hasn't changed. So we need this one in terms of N, the sprint. Stage 1 is 50, 100, 150. Well, that's 50 times N. 50 times 1, 50 times 2, 50 times 3. So the total distance will be 60 plus 50N. You really need to get good if you want to get the top marks at distinguishing when things are in terms of N and getting the answers to look like something like this without stressing too much. On to part C. In part C, in one of these stages, Phil runs slowly for 60 at 2 meters per second and then sprints 150 at 7.5 meters per second. Work out average speed. So average speed, I always get you to draw the triangle. Distance, speed, which is average speed, and time. Speed, based on our triangle, is distance over time. So we've just two parts to this question. We have 60 over 2, and we have 150 over 7.5, and then we need to combine them. Remember, the parts these are going to be the hardest parts. That's going to be 30, and that's going to be 20. So what have we worked out here? I hope you're all shouting that we've worked out distance divided by 2 meters per second is speed. So I've rushed this deliberately to show you. Just be careful, but does it change anything? This 30 is now time. Distance over speed is equal to time. So we have 2 times 20 plus 30, so you don't need to go and start scribbling out like this. The examiner will understand what's going on here. This is equal to 50 seconds. So what have we got now? We have total distance covered will be 210. This is my distance covered divided by my time, which is 50. And 210 over 50 is 4, remainder 10. 4 and 10 over 50 is 4 and a fifth. 4.2 meters per second will be the average speed. Multiply that by 50, you get 210. So we can kind of double check that we're correct in part C. In question 3, we're looking at a percentage question to begin with. Patrick, and it was Patricia, worked in washing cars for the weekend. In total, 35 cars were washed. Patrick washed 14 of them. Work out the percentage in bold of the cars that Patrick washed. He washed 14 out of 35. You're all saying, sir, we did this in primary school and we used to multiply by 100 over 1 for some reason. Well, it wasn't some reason. Your primary school teacher was just trying to show you the fraction of a whole number. And 14 over 35 is the same as 7 divides into both of them twice and 5. So 2/5, you all know, without a calculator. Patrick washed 40% of the cars. He was paid 200 sterling. He must have been working on the border. He converted this money to dollars. He was going on holidays, and the exchange rates are shown here. We've got two things going on. We've got euro to sterling and euro to dollar. How many dollars did Patrick get for his 200 sterling? So I always tell you with these questions, multiply and divide, and then tell me which one is right. So let's have a look at the exchange rates again. So we've £200 sterling. All we can do with what we're given is change sterling into euros. So if you multiply by 0.88, and we can see immediately which one is wrong, hopefully. And if we divide by 0.88, and I tell you to say, well, what's happening here? We've only got 88 cents sterling. We're going to end up with €1 whole or £1, say. So we're getting more. So whatever answer here gives more. And the second one to divide, obviously there's more smaller ones in. 227.28. This would be 88 by 2, which will be 176. So this is wrong. Show the examiner, you know this is correct. And then from dollars, from euros now, we have euros. We have 227 of them. And hopefully you can see from this one, we're going to end up with more dollars if we look at it in terms of 1 going to 1.18. So 227.28 multiplied by 1.18 would make it bigger. And I know you guys are probably just going to do it the correct way at this point of your junior cert cycles. 268 or 4th or 5th year if you're having to go back and revise, which wouldn't be good at this point. But the answer here, question 3B, which was worth 10 for A and B in total. So nice, easy enough start to question 3. In fact, that was all of question 3. Question 4, F is the set of factors of 12. List the 6 elements of set F. Well, we've got a box here with 6 elements. Just list them off here. First, 1 by 12, 2 by 6, 2, we're up to 3 by 4, and once these numbers become consecutive, we can't get any more factors. Now, I'd like if you did it numerically. 1 by 12, 2 by 6, and 3 by 4. It just looks better. You don't have to, there's no bonus marks for it, but you know, you're well able. And then underneath for 10 marks, it was 5 for writing out the factors. You need to know what factors means. The sets P and S are as follows. P, set of all prime numbers. What are my prime numbers? 2, 3, 5, 7, not 9 because 3 goes into it. And we probably don't have to go that far, but let's just 11, 13 would definitely be prime 2. Just going to give it roundy brackets. S, all square numbers, i.e. n squared, and n has to be natural. So 1 squared, 2 squared, 3 squared, 4 squared, and so on. Just do a few dots. Same up here, this will go on. So technically, let's do this. The Venn diagram below shows the sets F, P, and S. Just to confuse us, F is up here. So what are we asked to do here? So we just have to write each of the factors of 12 from part A into the correct region in set F. So let's put the factors from A and F. So here's the set F. So we know certain things about sets. Here's the intersection of all 3. Well, let's start in here. Just rub the lines out. So we have the intersection. We have F, and we have the 2 sets below that we've drawn. Is there anything common to all those 3 sets? Well, one is an F, but it's not in the middle one. And I'm going to write big P beside, so you can see this is P for prime, and this one was S. So I don't see anything common to all 3. F and P definitely have 2. I'm going to circle it to show that I've used it. That's definitely in there. 2. 3, 5, 7, 11. 3 is definitely here in F, and it's here in P. 2 and 3 definitely in here. Anything in F and S? 1, 4, 6, 1 definitely. 1 is there. 1, as is 4. 1 and 4. 1 and 4. There was 10 marks for just putting these numbers in. And then we're left with 6 and 12, and 6 is neither prime nor square, and 12 is neither prime nor square. So hopefully you got this question fully correct. Go and practice it. Be careful with the sets questions. Question 5, the final question in this video. Work out the value of this guy, substitution. Part B, multiply out and simplify. You're thinking to yourself, for real? And then a 4-term factorization, which you guys are brilliant at. So 3p, 3 times 6 minus 4t squared minus 4 by 5 squared. Your calculator will give you the absolute complete answer. Where does it come from? 18 minus 4 25s, which is 100, will give minus 82. There was 5, 10, and 10 for these three parts. 2x, if you want to just create your half moon, 2x by 4. Or some of you will write it out like this, 2x by all of this bracket, 4 minus 5x plus x squared. It's still a good way to do it. Minus 3 by 4 minus 5x plus x squared. You may not have time at leaving cert, but at junior cert, set it up like this. 8x minus 10x squared plus 2x cubed. And when we get to the second section, I'd be tempted to write the like terms underneath each other. We have minus 3 by 4, which is minus 12. No other number. Then minus 3 by minus 5x plus 15x. I'm going to plug it with the 8x. Draw a line and combine these two. And then minus 3 by x squared is minus 3x squared. So the highest power first, 2x cubed. I'm just going to write it, 2x cubed. So I've taken care of this one. Then I have x squareds minus 13x squared. They're just up above here. Then the x's, I have 23x plus 8 plus 15. And the minus 12 at the end. And just go back and double check all your workings, all your signs, to make sure you don't make a silly mistake with just multiplying out and simplifying. Then on to 4-term factorization. Pair the most obvious two together. 10 and 5 here. I'm going to take 5e out of the first and third terms. What does that leave me with? I'd have to have 2d to get 10de. Minus, I have 5ef, so just f missing. The second bracket has to be 2d minus f. So what's missing? Well, to get plus 2d squared, I'd have to have plus d. Does that give me the other term minus df? It certainly does. So we just have 5e plus d times 2d minus f. And do the order of the brackets matter? No, this is equal to 2d minus f times 5e plus d. But you continue to ask that question, does the order matter all the time? Is 2 by 3 the same as 3 by 2? Just ask yourself this question before tormenting your teacher. So get practicing this and you'll be flying for the exam in 2022.